like we have 8 attendees currently, and guessing a few more will join, but we can go ahead and get started. Thank you all for being here for the What's Happening with Solar Panel Recycling panel. A very convenient pun or play on words that fell into our lap. This is one of many panel discussions and educational webinars that Solar Oregon does, and I'm excited to dive into this topic. I want to introduce briefly now, and I'll introduce them more thoroughly later. We have Dustin Mulvaney from San Jose University, Bob Nicolson from SEIA, or Solar Energy Industries Association, and Chris Regis from Green Century Electronic Recycle. So thank you all for taking the time to share your knowledge with us all today. Today's agenda, some welcomes and introductions. I will go over a brief intro of why PV recycling matters, why we chose this topic, and then introduce our panelists more fully. And the bulk of this webinar is a panel discussion, and we want this to be interactive. So throughout the panel discussion, we encourage people to add questions to the Q&A box, comment in the chat, interact how you see fit. My name is Grace Hardy. I am one of 2 program managers at Solar Oregon. The other, Zach Snyder, is our tech support on this call. And we are a 42-year-old nonprofit. We've changed a lot over those 42 years, but we've stayed true to our mission to increase solar in Oregon through education, outreach, community, and advocacy. And so as part of that, we do educational webinars. We run regular How to Go Solar and Storage webinars. We do solar tours of zero energy homes. We run solarized campaigns, which are campaigns to get whole neighborhoods to go solar together. And we like to connect people through peer-to-peer education, because that's a great way to increase the number of people purchasing solar power, is through connecting people and sharing their stories. We are a member-based nonprofit, and so we'd like to thank any of you all who are members, and if you aren't a member, we encourage you to join. You both support our work, and you get discounts to our educational events and tours throughout the year. So please click this link up on the, or not click the link, type in the link. I'll post them in the chat up on the screen, and then also follow us on social media at Solar Oregon, or check us out on Eventbrite. That is where we will be posting all of our upcoming webinars and events like this one. Also want to give a huge thanks to Energy Trust of Oregon. They are an independent nonprofit. They provide resources to help all sorts of stakeholders make their energy use more efficient and affordable. They don't quite serve the entire state, but they serve clients of the major utilities listed on the screen, and they're supporting this workshop today and support a lot of the work that we do. So huge thanks for Energy Trust for their support. And our final housekeeping thing, if you have a question throughout this webinar, please put it in the Q&A box. You can find this in the bottom panel of your screen. And this just allows us to have all the questions in one location. Still feel free to use the chat to communicate with other attendees or panelists, but put questions in the Q&A box. And I'd like to ask you all to take a moment to fill out a quick poll that we launched at the beginning of our webinars, and this helps us understand who we are reaching with these webinars, so we can improve our content. Leave that open for just a moment. leave this open for one more minute. All right, thank you all for participating in that. So why does PV recycling matter? Why did we choose this topic for this panel discussion? As many of you may know, solar panels have quite a long lifespan. A typical solar panel warranty is around 25 years. However, there are many panels installed in the 1980s that are still producing electricity efficiently or effectively, and so the actual lifespan may be longer. The number of panels installed per year has also dramatically increased in the past decade. In fact, over 95% of PV modules deployed in the US have been installed since 2012. So because of these two things, because they have long lifespans, but most have been installed relatively recently, we haven't been forced to address what happens to solar panels at the end of their life. However, this will be changing soon as solar panels start to reach the end of their life and they are being installed more rapidly. So by 2050, the International Renewable Energy Association estimates that there will be 80 million metric tons of PV waste globally. There's a lot of work that needs to be done then to prepare us in the coming years to manage this waste in a manner that is both sustainable for our planet and for our people. And so with that background, I would like to formally introduce our panelists, all of whom have expertise in what it would take to make PV recycling work in the US and what this transition will take into the future. And so our first panelist is Dustin Mulvaney. Dustin Mulvaney is a professor in the Environmental Studies Department at San Jose University. Dr. Mulvaney's book, Solar Power, Innovation, Sustainability, Environmental Justice, was published by the University California Press in 2019. And he has a textbook, Sustainable Energy Transition, Socio-Ecological Dimensions of Decarbonization, which he published with Palgrave Macmillan in 2020. Dustin has conducted extensive work on the solar industry and sustainability, chemical stewardship, disposal and recycling, and land use impacts. So we're really excited to have him on the call with us today. Our next panelist is Bob Nicolson. Bob Nicolson spent the first 15 years of his career in the commercial nuclear industry, managing environmental programs with a specific focus on waste recycling and ISO 14001 system development at facilities across the US. In 2003, he founded Uniwaste Services Corp., a specialized recycling company that specifically managed mercury and lead-containing devices, including cathode ray tubes. He developed a collection of infrastructure throughout the United States, which was utilized by major OEMs. And in 2012, he co-founded Neo Energy LLC. Neo was developed to explore the potential for creating energy projects in the US that use food waste to produce renewable energy and convert the resulting material into organic fertilizer. And now he is the manager of PV recycling at SEIA, the Solar Energy Industries Association, working on their PV recycling program. And then finally, we have Chris Regis, the owner of Green Century Electronic Recycling. Green Century was founded in 2008 and is an R2v3 ISO 14001, ISO 45001 recycling company. Their services include end-of-life recycling for electronic waste, data destruction, ITAD, and universal waste services. And Green Century is a solar panel recycling partner of SEIA through their PV recycling program. So are connected in that way. So again, Big welcome to all our panelists, and I'm going to stop sharing my screen and jump right into the questions. So to pull it up. So to start us off, I'm going to throw it over to Bob. Could you start by giving us an overview of the current state of PV recycling in the US right now?
Yeah, absolutely. And hello, everybody. Thanks for joining us today. So I guess the best way I could describe the current state of PV recycling in the US is that it is very nascent. The volumes of panels that are entering the waste shed relative to deployment is very small. So that's the good news. The challenge for generators of end-of-life panels right now is really recycling capacity. There isn't a large number of recyclers, quality recyclers in the US that can effectively recycle PV end-of-life panels, but we're confident that that's going to change over the next maybe 18 to 24 months. But I think you're absolutely correct. Going forward in the next 10 to 20 years, we will see exponential growth in the number of panels destined for recycling. In our association, we fully support recycling. Our primary goal at end of life is landfill diversion.
Thank you for that overview. I'm going to now pass it off to Chris. Could you describe from a recycler's perspective what the major technical and financial challenges of PV recycling?
Yeah, right now it's mostly just there's hazardous materials present in the panels themselves. There's the high cost to dispose of like cadmium, arsenic, and other hazardous materials, and then low commodity values, so low scrap values as far as aluminum goes in today's market. There's also problems, not problems, but we've seen this in other electronics, that manufacturing will evolve as recycling evolves. So currently the way we recycle is the panel is kind of like a grilled cheese with all the precious metals and things smothered into one section. So currently the problem is we basically just remove the aluminum frames, shred the aluminum frames, the glass gets separated out into a cleaned cullet and kind of used in secondary markets. And then the EV film gets used in an alternative landfill. So the problems are kind of the high cost to recover some of these materials, the low commodity value on the other side, and then the presence of hazardous material like cadmium and arsenic. I would assume, as Robert was saying, as we get further into the recycling process, as more hit the landfill, we'll become better at recycling some of these things. Some of the CRT processors will come up with better processes. But for right now, it's sort of a cost advantage thing that is hard to overcome.
Jumping off of that, for anyone to answer, what technological innovations do you see on the horizon that would improve the market for PV recycling and maybe address this lack of financial incentive that exists right now?
I think I can add to that one by agreeing with Chris wholeheartedly that PV panels are designed and manufactured to be as indestructible as possible, and effective recycling requires as simple destruction as possible. So there's a bit of a conflict there, which makes it very difficult for recyclers to recycle the material. But as far as innovative things going forward, there are companies today, I hear from them every day, literally every day, that are developing processes for recycling of the panels, understanding that, again, to Chris's point, there's not a lot of commodity value in a panel, whereas in the case of a television set, at least there was copper value and at times plastic value and aluminum. With these panels, there's very little value in what small amount of copper is in there and what small amount of silver is in there. Not to mention, it's very hard to liberate those materials. However, there are companies that are working today on developing processes that can do that. There's also companies that are working with PV manufacturers and float glass manufacturers on developing processes to return that glass to the panel manufacturers. I personally think that's a little ways out, but I think that will also help on the recycling side in allowing companies like Chris's, giving them a market, a better, more reliable market for the glass streams coming from the recycling process.
This is Dustin. I would add to that. It seems like the hardest part of this is to get that glass to be much more valuable. There's a lot of polymer and metal contamination at this point. So it really, the destination of that glass is very limited in who will be willing to take it. It mainly goes right now to fiberglass and smelter flux, which is really pretty low value. I agree, returning it to flat glass is a pretty heavy lift because we don't really see high levels of recycled content in flat glass, but getting something to be bottle glass, I think, would be at least the next major step. And that, I don't know what innovations are on the horizon for that particular, but that's where I would be putting research and development money right now, is to get that glass to be cleaner and get it to a better, final resting place. And I'll just add one more thing that I think is not being, it will maybe be hard to value, but I think is valuable, are those silicon wafers. Right? Those silicon wafers are by far the most energy intensive stages of manufacturing a solar panel. So if you could recover and bring some of that silicon back into the feed stock for making next generation solar panels, I've seen studies 15 years ago that were saying you can cut the carbon footprint of a solar panel in half by doing that. So we need to really figure out how to get that encapsulant off of the wafers and that sandwich like that. I mean, that's the challenge, right? Is you really need to make a product that can live in the most hostile places on the planet, your roof and desert environments where you got all sorts of imperfections creeping into the panel over time, which hastens its degradation, and making that panel easy to take apart, like Bob pointed out, is really the challenge there, because you don't want it falling apart on your roof or out in the field anywhere. So
great. Moving beyond technical barriers, I'll start this off with Dustin, but anyone else who wants to add, what are the major policy barriers to PV recycling in the US? How does this differ from Europe in its approach to PV recycling? And then as a third part, absent to stronger public policy to encourage recycling of electronics, what role might standards and certifications play in enabling a circular economy in PV?
yeah, so by one account, it costs somewhere between $15 and $45 to recycle a solar panel, and it costs $5 to put it in a hazardous waste treatment facility and $1 in a landfill. So overcoming that economic hurdle, I think, is a high priority. And I think Europe has a much more advanced recycling policy because they have comprehensive across all the EU nations take back and recovery program, which requires that manufacturers recover most of the solar panels that are sold in Europe and then recover a large portion of the materials inside of those solar panels. In the US, we have a very patchwork set of regulations. We really only regulate the hazardous aspects of end-of-life electronic products. So that means there's a gray area, and a lot of that decision-making falls on the states, and the states are reacting differently. And that, I think, is going to be a major challenge in the next few years. You're going to see states enacting different rules, and that is a major problem. And I think, offers a suggestion, at least, that maybe we should have a federal comprehensive law or an industry-led comprehensive program. And we don't see those emerging in the US. And we've been looking for, I've been looking for 15 years now on this particular topic and hasn't quite gotten there. In lieu of state regulation or industry leadership on this, I think we have to rely on industry standards. Like, for example, we developed quite a few years ago an EPEAT standard that values recycled content and values recycled products or end-of-life products in a sustainability standard that, if you go to the EPEAT registry and look for sustainable solar modules, you can find some of those modules on there because they're awarded points for that. We also helped develop, this is in 2013 or so, with the Basel Action Network and eStewards program, and specifically updated the handling best practices around PV modules. So ensuring that that end-of-life modules that manufacturers or whoever is leading these programs with the state are directing these PV waste streams to eStewards, I think that would also help with the end-of-life recovery of materials. That's a mouthful, sorry.
I would add to that one of the advantages that Europe has is, or a couple of advantages, is that they have a very mature collection infrastructure from decades of focus on these sustainability issues. But they also, like in the UK, have a very high landfill tax. So their landfill tipping fees are higher than they are here in the US. And then there's, well, a couple of years ago, it was $100 per ton tax on top of the cost to go in a landfill. So there's tremendous incentive to find landfill diversion opportunities to save costs, because the economic playing field there has been leveled, as opposed to here, where it's still astonishingly inexpensive to put material in landfills in Ohio or in Oklahoma. That's really a difficult economic barrier to hurdle to get over.
Going off of that, Bob, what work is SEIA currently undertaking to increase the accessibility of PV recycling in the US?
Well, I think as far as accessibility goes, really not a lot at this point, because it's a little bit too early. What we're really working on is, first and foremost, we want to develop a list of what we're calling recycling partners, but companies that we can promote among our membership that provide recycling services. And these are companies that we've actually vetted, that we've gone out and seen the process. I do that personally. We look at things like insurance coverage, we look at certifications. So we really want to provide our membership with a list of recyclers that are located, geographically in strategic positions within the US that have the same commitment to recycling standards that we have. Now, that being said, unfortunately, today, there aren't a lot of recycling standards when it comes to PV. There are opportunities like the ISO 14001 environmental management system certification. We're part of the stakeholder group that's working on adding PV to the R2 standard. So I think that will bode well going forward. I also think that over time, we're going to see more external organizations get involved. So the Basel Action Network is a prime example. I think they could do great work in the space, because there are so many parallels between the work they've done on the electronic side and the work that needs to happen with end-of-life PV. So that's really where our focus is now, and for the next 12 months, is to build out that list of recycling partners that we have vetted. And then as volumes increase into the waste, come out of the waste shed and into the recycling network, we hope to help recyclers improve their technology and improve their coverage across the US by also working with logistics providers.
Thanks for that answer. Chris, as a PV recycling partner with SEIA, what have been the benefits of this, and what advice would you give another electronic recycler considering becoming a PV recycling partner?
Well, the value has been a lot in education. So the material and education that SEIA puts out, that Bob provides, we're able to take into our process, pass along to our customers, and help that along with our R2V3 and ISO certifications and quality assurance programs. It helps us to quantify the value of recycling to our customers. As both Dustin and Bob mentioned, in the US, we have a patchwork of, I think at this point we have 26 states that participate in some sort of legislated take it back program. I think all of them are funded by the original equipment manufacturers. So meaning the manufacturers of the electronics fund programs at the state level to reclaim some of this. So a lot of the reasons we wanted to partner with SEIA was to work on that network going forward. The things with manufacturing and processing and the technology behind recycling are problems, but the problem from our standpoint is education, getting people to know that there's recoverable materials. Here's how to properly dispose of them. Here's why you choose companies that are E-Steward, R2V3, or ISO certified. So it helps to partner with companies like SEIA or organizations with SEIA just to leverage that, get the word out a little bit more and quantify our commitment to the collection of these materials.
Great. Jumping over to you, Dustin, in your book, Solar Power, Innovation, Sustainability, and Environmental Justice, it shines a light on the injustices within the solar industry. So through this lens of environmental justice, what are some challenges the PV recycling industry faces, and what solutions do you offer?
I think that's a really great question, because we speak glowingly of the end point of recycling all these materials, but recycling facilities are pretty hazardous facilities to both work in and be around. So for example, occupational issues related to lead exposure. Now, solar panels are not the major source of lead exposure in an e-waste recycling facility. Even in 2050, they will not be, most likely, but there's still lead in those PV modules, and usually in those recycling facilities, cathode ray tubes, there's other kinds of things that have a lot of lead that point to not only occupational illness with workers and potential contamination, but they also can bring that home to their communities with lead on their clothing, lead on their skin, and then that makes its way into homes. So I think avoiding the repeat of environmental injustices like we see, like everybody talks glowingly of how we recycle all the lead in the US, almost all of it. Like we have a very circular economy in lead, but we also have Superfund sites and many hazardous waste sites where there's a legacy. I'm thinking in Southern California, the Exide facility, where there's a legacy of lead contamination in a community that's been there for a very long time. So we want to make sure that recycling processes avoid exposures to the most dangerous materials that they're working with, and are good neighbors in their communities, and are making sure that they're delivering, because a lot of this is framed in like bringing quality jobs to places. When we grow these recycling industry, we want to make sure those are really good jobs for people.
I'd just like to add to that. I think that the certifications help to diminish some of those injustices, because we have third-party audits that quantify and follow our material. And I think that's part of the value in education, is also educating people why we do ISO certifications, why we choose E-Steward, why we choose R2V3, and get people thinking about that from the beginning. Get the manufacturers thinking about that from the beginning, get the purchaser thinking about that from the beginning. Recycling in this country, one of the biggest differences that I see between Europe and the US is recycling is an afterthought here. Where in Europe, it's not, it's a forethought. It's thought about from the design to the manufacturing to the distribution. And we're behind on that.
And I'll add to that. So the European take back policy was about electronic equipment and making sure there's a final home for that. But it was paired, the WEEE directive, the Waste and Electronic Equipment Directive in Europe, was paired with the Restriction on Hazardous Substances directive, which was meant to eliminate or reduce the amount of toxic materials in products too. So if we want to make sure that solar recycling is as good to the workers and communities as we can, I think prioritizing elimination of some of the heavy metals that we still continue to use in the solar industry, I think should be higher up. For example, I've been hearing that there have been a few manufacturers who've made lead-free solder modules. There's always going to be a little bit of lead in the ribbons and things like that. But so that goes to show the forethought in terms of materials handling has to go all the way up to the design phase, so that you not only are recycling your material, but you have less hazardous material in there to begin with. And I'm not trying to scare people by saying these are toxic panels, because that's how this often gets amplified by maybe actors who are not in support of the solar industry in any way. But we do have an opportunity to replace the most toxic metals in these, and I think that could be a higher research priority for maybe not the industry, but even just kind of more broadly, like what are our alternatives there, and how do we get them onto the market?
Mm-hmm. Great. So kind of switching topic here, through our community outreach, we've been asked by residents who own solar systems what they should do right now when their panel reaches the end of life, or how they should plan for this in, say, 10 years. What advice would you give to these solar owners?
For me, it's very simple. When you recycle, you are best suited to look for a certified company, one that either has ISO certifications 14001 or 45001, or a complete set of certifications through R2V3. In the absence of that, I do think eSteward is a decent program. But I think that from an end user standpoint, that is the biggest thing that we need to educate on. There not only is there a lack of federal regulations on electronics recycling or collection facilities, there's lack of state regulations. So in the absence of choosing a company that just started up and it's Bob's Metals or somebody else, without certifications, it's hard to quantify where that material goes. And the practice of cherry picking and landfilling in our industry it's the worst. It's what we combat with the most and compete with the most. So from my side as a recycler and as somebody who believes in what we do, I say to the end users, if you're not going to choose Green Century, just make sure to choose somebody that says R2V3 ISO certifications. And then you have a quality assurance. You have some way to quantify that they're not just cherry picking and landfilling. And again, I think part of the value to partner with groups like SEIA is that we get a broader spectrum of educating people on the needs of certification and recycling responsibly.
I can add a couple things. I would tell them to call their legislator and get a landfill ban on solar panels in their state, and ask for extended producer responsibility laws like Washington state's.
That's great. I actually was just going to ask about, beyond them recycling their personal panels, if there's anything else, if they're just a passionate citizen that wants to increase recycling, if there's anything else they can do.
I'll just say, if I could just real quick, and then I'll drop. The reason I say that is because often it's not the customer or the homeowner who's going to do the recycling, right? You're going to have some professional as an intermediary. And that's part of why this is a very difficult topic to some extent, because there isn't kind of the consumers accidentally putting this in places they shouldn't. So you don't see, so typically the reason we see or where we see the first kind of rumblings of concern around end of life solar panels or any end of life anything are the local hazardous waste managers who suddenly start getting a product that they don't know what to do with, or is costing them a lot of money. For example, California passed the law managing end of life paint, because paint turned out to be like 50% or 40% of some of these material waste recovery facilities bill. So they went to the legislature and got the paint industry to pay for it. You know, some states, California, for example, has universal waste laws, and those are paid for by taxpayers, not the producers. So I think, you know, polluter pays principle says the producer should help pay for a large portion. I'm sorry, Bob, I didn't mean to interrupt.
No, those are all great suggestions. I was also going to add that, you know, citizens can really encourage any of their local municipal collection points to include end-of-life PV as an item that they are willing to collect. When you think about it, there needs to be a system to get these from point of generation to wherever they're going to be recycled. And, you know, it isn't reasonable to expect, like Chris's company, to go to a residence and pick up a 5-pound. You know, it really, there's the economy of scale. So, you know, if municipal collection points, existing collection points, could work with the state if need be to be permitted or not, if it's not required, it would be helpful for those collection points to be able to collect these panels from residents and small projects to allow the recyclers to go out logistically and pick up larger quantities.
Agreed. So similar to what you're saying, Bob, we have, like in Oregon, we have statewide collections. So Oregon E-Cycles program, where we have landfill bans, and as an operator in Washington and Oregon and California, with states that have similar landfill bans and collection requirements, the hang-up still seems to be around education. The money goes into making the program or creating the program. But, you know, in Oregon, we're 14 years deep into a program, and I would say still 40% of the population has no idea it exists. Yeah, we located our facility close to the metro landfill here, just so that we can get one last attempt to keep things out of the landfill as people are going to do the dumping. And again, I think that's where you leverage partnerships with organizations like SEIA, Energy Trust of Oregon, Solar World, community events and things like that, where you actually get out into the community and spend time educating people on the proper way to dispose of things, regardless of what the material is you're disposing of. You know, there's a right way to dispose of everything.
Mm-hmm. We have a few questions in the chat and in the Q&A. So the first one was from Doug. What other heavy metals or dangerous chemicals are in solar panels aside from lead?
Well, there's cadmium, there's arsenic, just to name a few. Dustin, I'm sure you can expand on those. There's silica, there's other things inside the silicon wafers as well.
Yeah, I mean, a lot of those are all like alternative technologies, like cadmium is going to be in thin films. Indium is one. In fact, indium is interesting because goes to the point about thinking about eliminating hazardous materials. It turns out, so indium's in all of our flat panel displays, and indium lung is a new term that the Centers for Disease Control has coined because of indium exposures in the pulmonary system. So, but that I would say lead is probably, and maybe glass dust would be perhaps another hazardous material. Glass is actually pretty hazardous to handle too itself, and you have electric shock potential issues with handling solar panels. So the metals, I mean, I think lead is really the main one that of concern.
There's also a question from Rachel on what the name of the program at Washington State is that has forced companies to handle recycling of panels. And Dustin responded, I'm just going to share that link out to everyone in the chat if you're interested in taking a look at that.
I believe it's the Washington Take It Back Coalition. Is that not right, Dustin? You're referring to?
Yeah, that's right.
We have Oregon E-Cycles, we have Washington Take It Back, and then we have sort of a national patchwork company that tends to manage those programs. That is also a for-profit business managing recycling programs and stakeholders to legislate. It's it's definitely worth doing some research on and learning how your federal government and state government is prescribing you to dispose of things.
I think it's really interesting to look at the differences, for example, between how Washington has handled this and how California has handled this very differently. Washington, I guess it's not implemented yet, but looking to have extended producer responsibility for producer cells modules in the state. They got to set aside money for its take back and collection, whereas California had just basically reclassified solar panels as universal waste, which makes it easier to move stuff around. It was holding up people who were experimenting. So I think that those are kind of two states to keep an eye out to see, which of those approaches leads to better success and recovery and things like that. So you kind of have an experiment set up. Now, seeing a proliferation of different laws is not necessarily a good thing, I think, but one of these models has to win out.
Looking in the Q&A box, we have a question from Martin. If old panels were simply stripped of any aluminum framing and then stacked, might such stacks become some kind of specialized building material used as backfill building blocks or roofing?
That's fascinating. I've never heard that before.
Yeah.
But it sounds like as a structural wall of some kind. Interesting.
I have seen them use the EV covers for like landfill cover, for alternate landfill cover and things like that. I haven't seen anything structural done with it. And as far as the process goes now, aluminum really is the most valuable thing that we're gleaning from the process.
And that's something that often happens. So often what happens, at least around where I am, the panels will show up to some sort of waste transfer facility, and then they'll take off the aluminum panel, the aluminum frames, and recycle it there, and then give it to you. So that's like the diminishing value of those solar panels sometimes is even lower because someone has stripped off those frames, and there goes whatever 25% or half of the value that you were going to get out of it.
Right.
I have another question from David. Has anyone done a study looking at what percentage of panels should be considered hazardous waste? Similarly, what percentage of modern panels are using lead-free solder?
I think the lead-free solder question is pretty small. So some manufacturers will make a line because they have to sell to a certain market that has a threshold, but I think it's relatively small. SunPower because of their cell architecture, used to be able to avoid lead altogether in their modules, but Mitsubishi for many years was always advertising their lead-free modules, but not sure what that percentage is. And the hazardous waste question is really complicated. It's not really clear what percentage of modules would pass or fail the federal test. And then California has its own tests. That's like a little longer residence time of that they leach the chemicals out of, and they grind it up in smaller particles. So California has a more strict hazardous waste definition. So you have material that's not federal waste or not California waste. You have material that's California waste but not federal waste. Then you have stuff that's hazardous waste both of California and federal. So it's a mess, and we actually don't have any clue because you'd have to test every module to get a good sense for that.
Another question from Martin. Will the waste problem, quote unquote, magically disappear / diminish in the event that thin film / perovskite gains massive market share?
My answer to that is no. The problem will not diminish. You'll just see more players jump into the game and try to make money off the problem. The answer will still always lie in education, certifications, forethought in manufacturing, and responsible material recovery.
I'll add that having thin films, having everything just made out of thin films would make recycling a lot easier, because you could just break it into small bits of glass and soak out the semiconductor materials. As opposed, it's the back sheet and all this other stuff that sounds like it's really hard to chop up and causing some of the contamination to occur. So to the extent that even glass on glass solar panels, I think will be easier to recycle than, you may have said that already, than the glass on Tedlar or whatever. So I can see there being less of an issue, but suddenly what's in those perovskites? Lead, lead halides. You got, I mean, some are lead free, but you're introducing, different materials that we don't know the occupational exposures to and things like that. So the recycling problem shifts, I would say, under more perovskites.
In the chat, Catherine asks, when we say end of life of the panels, is it the whole piece or some component which are out of use? If it's about a particular component, why are we not looking at replacing the dead component but dealing with the whole piece as it appears? Recycling the whole piece is costly.
When we talk about end of life, we talk about panels that no longer produce or generate power at a level that makes it economically feasible to operate. So I'm not aware of, certainly I should say refurbishment and repair is becoming more and more prevalent in the US. There are more and more companies entering the space now that are focused on taking panels that were considered end of life for whatever reason, and then putting them through a refurbishment and repair process to redeploy those panels. So that's happening, and I expect to see that happening more and more. But there's also the issue of weather damage. So, a hailstorm in Texas, I can give you a real life example. Hailstorm in Texas damaged 450,000 panels and damaged them to a point where they just can't be repaired. So just weather damage alone in the future could create an extremely large volume of end-of-life panels. But I think, and maybe this is based on opinion, but I think when we say end-of-life panel, what we really mean is the entire module no longer has any useful life.
I'll add, there's a tornado in Southern California, took out 200,000 panels. I forget what year that was, but yeah, so yeah, I think, I forget what I was going to say.
Kind of a similar question, but a little bit different. Looking at like the solar system as a whole, Martin asks, can you talk about the recycling options for inverters and also microinverters?
So from our standpoint, inverters are not really anything new to recycle. It's the same process as recycling like a typical piece of electronics, a wafer board or motherboard. The composition is the same. The process is very similar. Inverters are something we see in other markets, so it's not specific to just solar panels. So it's not really an issue for us in the recycling world. The issue really does lie in the way that panel is made, like a grilled cheese and all that stuff in there for us with the solar panels.
I was going to add, so I remember what I was going to say before, which was related to Bob's point about the second life for some PV modules. A couple of years ago, I had a master's student interview the folks from PV Cycle and asked, what were the big surprises you found after setting up this take back and collection system? And one of their things that they found was that they didn't realize how big the reuse market would actually be. So having a centralized collection system early on led to, it being a little easier, I think, to get modules into people's hands that are willing to deploy them in whatever, on a water pump or somewhere where you're not going to redeploy those in a power plant, but you could find second uses of those everywhere. So I think it speaks to setting up a take back and collection system early. The other thing they found surprising was a lot of the PV modules didn't come back yet. So they're out there living, still generating power. So that's the good news on the good news side. So we get storms that take out and bring suddenly waste in bulk, but some PV modules are going to stay out there for 40, 50 years before they come down. So that's something that's hard to predict, but I think a dynamic we'll see.
Doug asks, are the more environmentally friendly panels more expensive?
Depends on what aspect you're thinking of there. Like if I were to try to characterize what makes a PV module more sustainable or not, I might look toward, how much coal is being used in the supply chain, for example. And I think places that have a lot of coal in the supply chain might be making PV modules a little cheaper. So I would say you probably do have to pay a premium for PV modules that are, well, let me think of it this way. Companies that are participating in some of the standards, sustainability standards that I was mentioning earlier are premium solar module manufacturers. So you're definitely going to probably pay more for, I say definitely probably, you'll definitely pay more from a premium PV module manufacturer than whatever tier 2, if they even exist anymore. I don't know.
In my experience, personal experience with solar and putting solar panels, employing them, where it was about a 10 to 15% more expensive to use a manufacturer that at least had sustainability in their ethos or in their manufacturing process. I mean, part for me is trying not to buy stuff from China as well, but you get it's about a 10 to 15% price hike from my personal experience with it.
Great. We have a question from Martin. At the 2021 ASES conference, I talked to a presenter from the Pine Ridge Indian Reservation. He said that old panels would still be welcome despite their lower output. There are 40-year-old panels still outputting 70%. Can you comment?
Yeah, I've heard similar stories. So I've run into people who have PV modules from the old Arco solar power plant on the Carrizo Plain that was built in the early 1980s. So those old panels, they have the circular wafers, so you can usually tell the oldest PV modules. But that makes sense. I think that goes exactly to what they found with PV Cycle, that there is an appetite for modules that don't put out 100% of what they did if the tasks are appropriate. The challenge is you probably want to have some kind of recertification of some kind to, if you're going to really develop a market there, to make sure that the modules the modules have been characterized to some extent, make sure they're putting out a consistent amount of power, or they're labeled appropriately or something like that.
Yeah, I agree, Dustin. I think that you would want to have some quality assurance programs written so that you had a minimum efficacy, like 70% output or 75% output, and then you'd want to have some way of recapturing those panels should they fail. I think that's a big challenge with waste in general, is upcycling, refurbishing, and what that really means to the final reclamation and disposition of the material.
Wish cycling.
Wish cycling, that's a good term. Yeah.
Our last question in the Q&A box is from David. It's directed at you, Dustin. Based on your suggestion for a landfill ban, do you think all solar panels, even those passing a TCLP test, should be considered universal waste?
Well, the reason that they all need to be treated as universal waste, and the reason that California decided to do that, is because you can't tell by looking at the module whether it would pass the TCLP or not. So there's not enough information on the module to visually say whether or not it's universal waste. So they decided to say, well, we're going to call it all universal waste. We're going to relax the rules on handling the hazardous stuff. It's probably not that much different than the stuff that passes the test. But we have to treat it all as guilty until proven innocent in this particular case. So you'd have to do hazardous waste determination test on every module to prove whether or not it's hazardous or not. And not every manufacturing line. So even manufacturers who have different vintages of modules would have to have different. The whole toxicity characterization test is pretty complicated and convoluted to some extent. So the easiest way they decided was just call it all universal waste, and that means every single PV module is handled the same exact way. And that's probably the best way to do it. Not necessarily the universal waste part, but making sure everybody's handling things consistently.
Going back, I found one more question in the chat that I missed from Doug. It says, will you spell out indium, which I think Chris did, but I don't think it went to everyone. It's INDIUM, which also is contained in flat panel screens, and he is interested in learning about indium lung disease.
I would Google CDC indium lung, Centers for Disease Control and indium lung, and you'll find at least a dozen papers on this topic. And it's largely coming out of case reports out of Japan, where there was a lot of flat panel display recycling, including like cell phones and things like that.
We have another in the Q&A box that just popped in from Martin. Considering that panels encapsulate the potentially hazardous waste, shouldn't it be acceptable to just pile them up in landfills? There are no leaking heavy metals.
Probably. I mean, if you've gotten to the point that would be okay. It's just, I think we do have a little bit of a space issue with landfills. I don't think landfills are trying to divert waste also. So yeah, yes and no. I just think there's too much valuable stuff in there to want to landfill, and it might not seem valuable now, but in the future, especially that silicon, I think is really, from an energy perspective, much more valuable than it's given credit for right now. So I think in the future that stuff should be probably put back into other silicon products.
Do you think the value, Dustin, just because the amount of resources it takes to mine and new silicon?
Yeah, the refining process to get it to be so ultra pure just requires so much energy inputs that Solar World, who became spun off a recycling entity called Sunicon in the late 2000s, they had done some work to show that the grams of greenhouse gas emissions associated with a recycled module or one made from recycled wafer would be about less than half of the greenhouse gas intensity. And that includes some of the reprocessing of the material, because you just spent 70% of the energy use goes into just getting that wafer to be so pure. So you're losing a lot of energy value there.
Hey, Grace, my apologies. I have a hard stop at 4 o'clock, but I just wanted to say, I think everybody has my email address. So please, if there's any other information or questions anybody has for me, please feel free to reach out via email, and I'm happy to continue the discussions.
Thank you, Bob, for joining us. And
nice to meet you, Bob.
Hi, Bob.
Thank you, Bob. It was really nice to meet you.
Yep, you too. My pleasure. I'll talk soon.
Have a good day.
Well, I want to respect your time too, Chris and Dustin. It is 1 p.m. here on the West Coast, at least. And for all of the attendees still on, this webinar has been recorded. It will be posted to our YouTube channel. I will send out an email to all of you who registered through our Eventbrite with a link to that YouTube channel. I will put Bob's email in there as well. And feel free to reach out if you have any further questions. Thank you all for joining us today in the middle of your Tuesday. And thank you so much, Chris and Dustin, for that lovely discussion.
Yeah, thank you, Grace, for the invitation to participate. And Dustin, thank you. I found your information really useful. I really appreciated it. So I hope both of you guys have a really good rest of your day.
This is great. Yeah, thank you for hosting this topic. It's not a very popular topic.
We get a
So I'm
surprising
glad
amount
that
of
you're covering
questions about it. Yeah, it's a neat that people are thinking about it.
Yeah, that's really great. So awesome. Thank you, and great
All right.
work in the future.
All
Bye.
right, see you. Thank
Have a
you.
good day. Bye.